Hello, welcome to Ekidel, where we train future civil and structural engineers. My name is Fashe Ochet. Today, we are going to continue the part 8 of this particular drawing. And I want to say, sit tight because we are going to be talking about the foundation. And quickly, let me quickly highlight what we are going to be doing in this part. In this part, I'm going to be showing you how to know your column load, the total axial load. Understand, at the base, at the foundation level. Is that okay? Let me click on this. Like this one now, we are going to know the total column load. Is that okay? The axial load on each of the columns are carrying. I'm going to show you in this Protastructure 2018. Is that okay? And also the kind of foundation we are going to be using in this particular design for this structure is going to be what do you call it? Beam raft. But before we get to the beam raft, I'm going to be showing you why we are using beam raft, because there are a lot of things I'll be explaining in this foundation and how to model your beam raft. Everything I'm going to be mentioning it in this particular video. Is that okay? So I haven't explained that now. Let me go back. Okay, so in case you want to know how we came about this, how we got to this place, I want to say go and watch the previous ones we have done, part 1 up to part 7. Before this part 8 that we are dealing with what with the foundation, because we have explained a lot about this particular video, and as I promised that I'm going to do it up to the foundation stage. So let's see how far we can go with this. Is that okay? In this foundation. All right, so but before we go into that, I want to also say that thank you so much for those who have been subscribing and also that have been liking our video, and for those that have been commenting in some of the videos. I want to say that please, your comment is also highly welcome. Is that okay? And also don't forget to always like our video. Is that okay? Thank you so much, and tell others about Ekidel. So that is we really appreciate all of you. All right, so let's now see how we can go about the foundation of this. As you can see, the structure has been properly designed, analyzed. Is that okay? We have done the interactive design and all of that. Okay, so now let's now go, and the method of analyzing this particular structure, we have explained it. Is that okay? This analyzing of this structure is totally different from how we normally analyze the other structure. Is that okay? All right, so now if you want to know how we came about that, watch our previous video. You'll get to learn a lot about that. All right, so let's now go to foundation. First of all, I said we are going to know the kind of what they call it, how to bring out your column load. Is that okay? Total axial load on all of this, and also how to calculate it maybe manually. Is that okay? To arrive at the combined load. Is that okay? All of this we are going to be explaining it in this video. Don't forget that we are using a Euro code in this particular for this particular design. We use Euro code, not a VS code. Is that okay? And I'm going to explain the difference between them in terms of this. Is that okay? All right, so that is that. All right, so let's now go. How do we now get the column load? Is that okay? Of this using a Protastructure 2018. For you to know the column load here, you can come to this place. Can you see this place now? Active window settings and visual interrogation. I'll click on it, and once I have done that, before we do this, let's do our what do we call it, bearing capacity setting. Is that okay? So for me to do that now, I'll come to my analysis. Where's my analysis? Come here and click on building analysis, because it's very important. Is that okay? To set our bearing capacity that we are going to be using for this particular design. All right, once you get to this place, because the interface of this Protastructure 2018 is different from that of 2022, 2024, 5 and 6. Is that okay? So but when it comes to 2018, this is where you come for your settings. Is that okay? Come to parameter and come to what? For foundation. From the foundation, you can now see that the default allowable stress of soil is what? Is 200. So based on our own assumption, because an assumed this thing is what? Is 180. Is that okay? Which in our general note, because one thing you should know that it's not all the client do what we call a soil test. So it's your own to now check the area and assume, and in your own note you have to put it there that this is your assumed bearing capacity that you use, that you have used, and before they carry out the construction, they must do their soil test to ensure that it's not less than 180. It can be equal to 180 or greater than 180, but it should not be less than 180. It must be in that your note, general note. Is that okay? So that if they see it, they know that they must carry out that particular test, because at that time that you are designing this, they might not provide it. They might tell you just use so bearing capacity from the architect, or I'm saying this from experience. Is that okay? Because not whether you like it or not, it's not everybody within Africa. It's not everybody that does what soil test. Is that okay? There are some structures they will just ask you, just do this, just do that. Is that okay? But for your own safety, what do? You put that note there that this is what you use, and they must ensure they do it. And if they now ask you to come and do the construction, you must insist that yet you must insist that they should do the soil test, because this is what you need to confirm if what you have used is okay. But if they give it to another person, then it's the responsibility of that person to ensure that yes, he or she stands her ground, that you must do that soil test to ensure that what he has, this he or she gets this 180 as the allowable stress of soil, or more than. Is that okay? If it's more than, good and fine. So but it must not be less than this. Is that clear? All right, so based on our own, we are using what is what 180 allowable stress of soil. So I can now click on OK and then click on yes. Is that okay? And all this have been done. The settings here have actually been done. I will now click on what on okay, yes, I'll click on close. Now, having explained that aspect, I'm talking about practical, what is happening, isn't it? So which is very, very important we talk about it, so that at times, so that when you now go and want to design and your architect telling you use this, also this, and you might lose that job. That's just the truth. But for you to be on the safer side, it's good you put on that note that is what you use, and you must ensure what I've just explained to you, so that you can clear yourself. Is that okay? All right. Now let's now see how we can now generate our axial load, total axial load for each of the column. So I'll come here now, come to this. Then from this particular place now, where we are seeing the active window settings and video interrogation, I'll come to my column plan and display. Click on this. Then from this place now, you can now see axial load. It will be like this. You can now see your axial load here. So check it. And once you check it, this place will be what active. Now where you are seeing this place now, we are seeing top and bottom is where you want the load to appear. You want to appear at the bottom of the column, not at the top. Is that okay? So that is because we are dealing with foundation, isn't it? I'll now come here. So if you look at this now, you can see select all. If you select all of them, automatically everything will be selected. Can you see now? As I click on it, can you see what we have? All have been selected. Can you see them? Can you see all the load combination, the total axial load? Can you see them now? But this is not advisable. Is that okay? All right, you can just do that for your own checking. That's when you want to play around it. But when you are dealing with, we are serious with your work. So instead use a G plus what? G plus Q. And if you are using G plus Q, if I click on OK, so you can now see what I'm having. For example, this particular one now. So if you now add this one now, let's now add this one. Let's see. If I should bring this one out now, let's say I'm bringing this one here. Let me see, I'm bringing this one here. Is that okay? Let me see, I'm bringing this one here. So this plus this now, this is 1247.6.6. Is that okay? Then plus 305.5 equals to what? Equals to this. Then multiply by 1.3 because we are using 1.3. If it's a BS code, it's 1.5, 1.4, isn't it? So plus times this. No, this is life load and dead load. Sorry, life load and dead load. Let's go ahead. Let's do it separately. This one is dead load, which is a 1247.6. Okay, 0.6. Then multiply by 1.3. Is it 3 or 3.5? That's for if it's BS code, it's a 1.4 as dead load. But if it's a Euro code, it's 1.3 or 1.5, something like that. So I'll now click on equals to. So I have this one now, 1621.88. 1621.88. So I'll now keep that one aside, 1621.88. Then what about this one? 305.5. Then multiply by 1.5. Multiply by 1.5. 1.5 equals to this. So this one now plus, I think we have a what do we have? Sorry, let me see it again. 1247.6 multiplied by 1.3. Sorry, that's a mistake. Let me see. Cancel. Okay, 1248.6. Am I correct? That's 1248, 1248.6, 47.6. Then multiply by 1.3 gives us what? Okay, 1621.8. Is that okay? 1621.8. I'll now come here. 1621.8, 0 this point 1621 is 0.5, then multiply by this 0.5 equals to this plus 1621.88. What do we have? Can you see 20 what 2080 point this? That's what we are having, isn't it? That's what we are having as our total axial load. But how do you now get the real one from your software now? This is the manual way. So I'll now come here now. I think that dead load is 1.35. I think so, yes, for Eurocode it's 1.35 instead of 1.4. All right, so I'll now come here now. If I want to get my real distance now, I'll now use this one. I'm not going to use this one. Is that okay? I'll go ahead and use the factored load, the factored one, which is this one. Can you see G plus Q and G plus Q factor? So I'll click on this one and now click on what? On OK. So can you see it now? You can see 2000 plus 2001, 2017, and what I have is the 2080. So can you see what I have now? Can you see that it's very, very close? So this is how to get your total axial load combination 2. Is that okay? This is it now. So I'll now click on what? On OK. And I have this. Can you see now? I have my what? Total axial load. Is that okay? Total axial load. So this is how to go about it. Since we are using Eurocode, this is how to go about it. Is that okay? Alright, how to calculate it manually, your total axial load. Add your dead load and dead load and your what do you call it? Life load together. You can see what we have as we use our calculator, and if you now use that of a factored load, G plus Q plus G plus Q factored, you can see what we are now having here. This is 2017 and our own we got a 2080. Is that okay? All right, so that is that. So I've shown you how to do that. So the next thing now is to design. Now if I want to use this one now, for example, let's say we are using pad footing. I'll right click and come here and do what? Insert pad footing. So let's see now, if I'm using, let's see, the depth of 400. Don't forget our bearing capacity is what? 80. So and everything here, let me see, I'm using 20 here. Is that okay? 20, 16, minimum of 16 and 20. Sorry, y direction, x direction 16, y direction this. So let me just use 16. Let me use 16 for them. All right, concrete cover is 50. Everything is okay. Then I'll now click on what? On calculate. So can you see section what? Section is sufficient. You can see how it's filling woefully. Is that okay? Can you see? As I square it, can you see what I'm having? No matter how I increase, can you see it's even filling on punching check? And once it's filling on punching check, what do? Just click on OK and come here and increase it. Increase the depth. Let's say I'm using 600. 600 now. You click on calculate again. So can you see it's still filling on punching? Let me square it. It's still filling on punching. Let me say I won't increase it. Is that okay? Let me say I increase it. Can you see it's still filling? And if you look at the spacing is this, so let me now make it let's say 800, which is not ideal because the highest you can use is a 600. Is that okay? When it comes to pad, the highest depth you find footing depth you can use is 600. So let's see if 800 we go calculate. Can you see even it's still failing on punching, which automatically that area we cannot use pad. Is that okay? It will never work. Can you see? It will never work because despite we are having what? Square it 3,500 of our pad. Can you see with the depth of 800, yet it's still failing at what? At punching. So automatically this one will not work. Is that okay? All right, let's go to another one because I have to consider those ones that are high somehow. So let's see other ones. It's this area that should be high. Okay, if I click on this one 1000 plus, I'll click on this, right click and click on a insert pad footing. Okay, let's see, we are still using it 600. Let's see, can you see also square? Can you see at this one minimum, which is 100, is still okay? It's not less than 100, it's still okay. This one is also okay, but if you look at it in punching, it's still failing. Is that okay? If I come here now, let's say I'm increasing it to, let's say 700 for example, then 700 for example, and then I click on calculate. Can you see it's still failing? So with all of this, it indicates that it shows that yes, we cannot make use of what? Pad will not work for this. Is that okay? Pad will not work for this. So if I now say okay, the next type of foundation that we might be thinking of is what? Is a Y shape. And most of the times when your design is filling on pad, for you to now talk of a Y shape, definitely you might still encounter some kind of failure that will make you to change your mind. So on that note now, I will not bother myself on going for pad, or let's just go ahead and see. Is that okay? Let's go ahead and see this. So for me to insert my listing, let's see, based on this load, let's say I'll go to my foundation. I just want to use this one to show you. Is that okay? how you take your decision, because automatically looking at this load, you know that yes, pad will not work. Is that okay? So, and I will not even think of a what they call it, a white strip. Is that okay? So automatically just go straight to our main purpose, which is what? Which is a what do you call it? Beam raft. Is that okay? Not to waste much of our time. So we are going to be using a beam raft for based on this kind of loads. Can you see? Based on this kind of load that we have on this structure. Is that okay? Based on all these loads that we are having on this structure, so we are going to be using that. Is that okay? We have some plates that are very, very small, like this one is very small. Is that okay? You can decide to use a what they call it, patch. Is that okay? But since majority is going to be what white strip, we are going it's going to be beam raft. Let's just go ahead and do that. All right. I want to explain all of this now. Let's now see how we can design our beam raft. So I'll come to this place of concrete. Come to beam, concrete beam. Yes, I'm going to be using this 225. I'm going to be using let's say 1,500, or let's just 1,004 for now. 1,400 is okay. 1,400 for now. Let's see. Yes, it's okay. So I'll now come here now, begin to insert. Is that okay? All through. Let me see. Is it splitting? Okay. Okay, this one did not split. Let me delete it. Let me take the property of this property. Then come here, click from here to this and also to this. Okay. Okay. Then let me go again. Let me see. This one will go straight. This one split. Okay, that one splitted. So from here also, let me bring it to this one here. Okay, you have to be checking also. Can you see it's splitting? It's splitting, so no problem. So I'll also come to this place again. Sorry, come to this place. Let me take the property and proceed from here to this. Right click from this one to this one. Right click, and also let me come to this place. From here, I'll come straight to this. Okay, and also from here now, from this one to this, and from here to this, and from here I take it to this. Then just like what I have from here also, I join it with this. So this one no problem because it's a beam raft. Okay, so looking at this place now, I have to split it because of the area, because if I not split this place, it might be asking for what? For thick depth, or a big depth of what? Of slab. So let me just split it here. Is that okay? Alright, so that is that. I also come here now, do the same thing, connect this one. Is that okay? Connect this one here. Okay, so let me just pause this video so that I can to reduce the length of this video. Is that okay? Let me pause it. Is that okay? When I finish inserting the beams, then we'll come back together. Is that okay? Alright. So as we can see, we are here already, so you can now see what we have achieved. Now if you look at this column now, the reason why I put this one here is because if I delete this one now, this only one might not be able to hold this particular one alone. So that's why I have to do along a y direction. Is that okay? So that these two will be able to hold this column. Is that okay? Alright, that's the reason for this shape here, this one we are having here. Is that okay? Alright, that is that. So now let's now check our 3D and see what we have. Correct. Can you see what we are having? You can see what we are having here. Is that okay? That is fine. So now how do you now go about the slab now? I'll now come to this place now, plan back again. So if you look at it, let me pick my slab. Where's my member? Can you come here? Slab. Correct. Now if you get to this place, don't forget that our beam depth is what do we call it, is 1,400, isn't it? 1,400. Is that okay? Then if you are now using what's going to be the thickness for our slab, our thickness of slab you are using, let's say we are using let's say I'm using 175 for example. Yes, I'm using 175. That's my slide because of the area. I'm using 175. So I'll now come here now, come to this place. I'm coming here. No, come. Concrete cover is 50. It's 50. Okay. So then the next thing, let me come to this load. My load is normal load. Is that okay? I'm using the same load. There's something okay, relative level, correct. This particular place now is very, very important. This particular place, I repeat, is very, very important. So now, how do you do the calculation? We say we are using our slab thickness to be what? 175 rather. 175, let's confirm it. 175, alright, okay. So I'll come here now, pick my calculator. Then 1,400 minus 175. Is that okay? Click on equals to what? That's 1,225. 1,275 here. 1,225 1225. Let me confirm it again. 1225. Perfect. And what does that mean? It means that this particular place beam, they are going to backfill it. The backfilling of this place will be up to 1225. Now the remaining 175 will now be what? For the slab, which now makes a total of what? A total of 1400. Is that okay? So what I'll do now, start clicking this one, begin to insert it now. Begin to insert it. I haven't done those settings now. Click on this, then this one. Okay, let me just continue with this. Okay, it's not going. Come here. Okay, let me press delete. I'll do that one. Come here. This one, this one, this one, this one. Okay, and also this one here. So in this place now, I'm going to change it. I'll come here now. Come to this place and use a insertion point. I use what? Pick point. Click on pick point, and I can now pick my point. This point, this point, this point, this point, this point, and finally this point. Can you see it now? Then I will do that now. This is a Protastructure 2018. Click on this and come down and click on this. Then come here again. Let me set my point. I'll start from here, from this point here. Okay, this point here, this point here, this point here, and finally this point here. Coming this point. Okay, why is it not coming up? Let's see. Click on this one, come back here. Sorry. Okay, let me do it again. You have to give me, let me start from here. Pick point here, then the next point. Okay, then followed by this point, this point, and finally this point. Okay, something's wrong. Let's see. Coming. Let's see. Let me click on save first. Let me save this first. Okay, so let's see. Let's try it again. Click on this, right click and click on property. Sorry. Click on this one, right click. I'm taking the property. Okay, let me just go back. It should be properties of this. No. Let me escape. Okay, let me pick my slab. Let me go to my modeling, pick my slab. Okay, everything remained the same. Let me see. 175. This is my 50. Then come here now and put, okay, everything's okay. This is so 1225. Is that okay? I'll come here. Let me see. Go back to general. Pick point. Okay, let me use the beam region first. Okay, it's not working. Come here. Since I'm here, let me pick this point. Let me pick this point, this point, this point, this point, and finally this point. Okay, something is wrong. I'll come back to that. Is that okay? I'll come back to that. Let's see what we have done so far first. Let's see what we have done so far. What we have done so far. Okay, so can you see what we have now? You can see what we are having. Is that okay? Let me remove from design status. Is that okay? Let me remove from there. So come to this. Where is it? Okay, no. Come to this place. Then scroll down. Let me see. Scroll down. Where is it? You can make it none. Then click on OK. So you can now see what we are having. Is that okay? So you can now see that place that we are going to be backfilling. If you look at it now, you can see the place we are going to backfill. Can you see it? You backfill under here. Can you see it? When you backfill it up to this level and compact it properly, is that okay? To remove all the voids, is that okay? So now what next? What's the remaining 175 will not be what? This slab. As you can see it here. You can see this slab here. Can you see it? So you can see it now. Alright. So now I haven't explained this. This is how you model your beam raft. Is that okay? There are lots that we are going to be discussing in this particular aspect. So let's now proceed. So now this place, how do I want to achieve? That's why your thinking is very, very important. Is that okay? So you can see I deleted this particular beam. Is that okay? So it was like this before. It was like this before. Can you see it? It was like this before, and it was giving us challenges in inserting our distance. So what I think, I was like, okay, let me delete this particular beam first. Is that okay? And let me have this environment. Is that okay? So now say, okay, if that's the case, let me now go back now. Is that okay? And pick my slab. That's why when you are designing, you have to think of how to achieve what you want. Is that okay? 175. Is that okay? Then this one is 50. Then come to this, and then our relative level is what? 1225. Is that okay? And I came here, insert. Can you see now we have this? So since I have this one now, I can now go ahead. Is that okay? I can now go ahead, close this one now, click somewhere else. I can now go ahead and insert my what? My beam on this. Okay, it's not aligning. Okay, it's not aligning. Let me just adjust that. So let me adjust this one now. Instead of using this axis here, I'll use this one. Let me use this one. Okay, it's still fair enough. It's fair enough. So it's still in line. So this one now, I can delete this one. Let me see. Then pick out the property again. So I'll pick my property again. Let me see. Where is it? So it's left for you. See, I'm taking my time to explain it. Let's face this challenge together and see how it can be solved, isn't it? So click on this one. Let's bring it up again. This one, 175, then 50, then come to this place and make it what? 1225. Is that okay? Come here again. Click. Can you see now? Fixed without any issue. Can you see it now? So we have successfully achieved this one that's giving us challenges. Is that okay? So now we can now come here now, 3D, and let's see what we have. Can you see it now? Properly modeled. Can you see it now? So this is how to go about it. So once we are done with this one now, So the next thing now is we have analyzed the structure, isn't it? Let's check our design status. Let's see. Come to this. Okay, it's still intact. Is that okay? It's still intact. So I can now come to this place now. Where is it? I'll come here now. Where is our foundation? Come here. All right, I'm going to draw our slab strips. Is that okay? We are going to be drawing our slab strip for this. Is that okay? So I'll come to where do we have it? I'll come here. You can see slab strips. Is that okay? I come here and click, and let's wait for it. Correct. So now I'm going to be dealing with X direction first. I'll click on this one. It's active now. Then I'm not going to be using analytical strip. I'm going to be using what? FE strip. Is that okay? And from FE strip, what's the condition of this? The boundary condition is beam to beam. Is that okay? I'll come here. This beam, start from beam and end in beam. So which is here, from here like this. I press my control key to have something related to this. Let me delete. I don't want this. Something like this. Okay. Let me use my eye gauge for this. Let me come closer. Yes, I have this, and also this one again. Let me say I have something like this. Then this one again. I have something like this. This one again. Come here. I have something like this. Is that okay? So this one again. Let's see. Okay, I'm having this. So I'm still on X direction. Can you see it's active? So let me also pause this video so I can draw it to reduce the length of this video. Is that okay? But at this point, in case you have not clicked on like button or subscribe button, I want to say you should do so. You can see how we are taking our time to face the challenge together. Is that okay? So that's not just be the how it's going smooth. We are only watching at least the challenge and how we are trying to solve, how to think on how to solve issues. So you can also see it here, which will definitely help you also, even if you watch this video and when you are handling your own, that okay, I should be able to achieve this even though I'm facing this kind of challenge. Is that okay? All right, so that's fine. So let me pause this video and do the rest. Is that okay? Both X and Y. So you can now see we have successfully draw this particular. There was no any challenge. Is that okay? If not, I will have brought it up for us to see. Just everything went smooth. All right, so now that we have done this one, now the next thing is to do what? Is to analyze this and design this slab. Is that okay? So in analyzing this one now, we are going to come to our list of what? Analysis. And this time around, we are not going to be using FE analysis. But first of all, let me save this work first. Let me save. Is that okay? All right. So now I'll come to this place of analysis. Come to this. We use a FE Raft foundation analysis. Is that okay? I'll click on this. Click on this. Okay. Now at this stage, I'll use what? Use the subgrade reaction. I'll click on it and also include column. Yes, of course. Then this one now. This one is optional. Yes, because at times you might encounter some error that the only solution is to remove this. Is that okay? It does not affect your structure. It's still okay. Is that okay? All right. So but for now, let's leave it. So this one, apply life load. I will not apply life load reduction on this. Is that okay? And I will not use a space solver. Is that okay? So this one and this particular one is okay. But if it's a big structure, yes, that's when I can apply this what? Life load reduction. Is that okay? Now at this point now, I can now click on what? On Raft foundation mesh and analysis. Is that okay? I'll click on it. So let's wait for it and see what it's going to come up with. All right, can you see loading pre-processing processor or something like that? All right, so let's wait for it. Is that okay? So we also have what we call a Ekidel mentorship, whereby we train specially, where you can have access to what to ask questions, and also we bring out, we bring up the the practical aspects and some challenges that possibly one can encounter at site or during construction or during design, and how to go about it, and some error that you can ignore and those ones that you cannot ignore when you are using a software. Is that okay? And also we also have a what we call Ekidel group. Is that okay? And in this group we do a lot, whereby if I face any challenge, I can quickly post it there, and before you know it, all other engineers assist me to help me solve it. Is that okay? All right, enroll today for Ekidel mentorship class. It is very, very important, because there are a lot of things that I might not be mentioning in this video. Not that what you are doing is not correct, perfectly correct, but there are some advanced aspects that I might not be mentioning. Is that okay? Which is meant for what? For the training, those who have enrolled for the mentorship class. Is that okay? All right, so thank you so much. Okay, I'll click on this and let's wait for it. Okay, let me pause it. It's still loading. Let's wait for it. So can you see it has finished? Is that okay? Now it has finished. So the next thing I'll do, since I'm using Protastructure 2018, is that okay? I can click on this particular one called close, and let's wait for it. Allow it. Let's allow it. It's still loading. Can you see calculating the mesh result? Let's wait for it. All right, here it comes. So we can now see what we have based on the soil, aligned source of soil that we have already entered as our settings. Can you see it here now? So it's very important that before you design your foundation, when you are doing your model, you can ignore this particular soil strength. But once it comes to foundation, the first thing to do, make sure you enter your soil bearing capacity. Is that okay? Then once you have reached this stage, now you can click on what? Analysis post processing. Is that okay? I'll click on this and let's wait for it. Is that okay? Let's also wait for it. It's coming up. All right, so we have this one here. So since once you get to this stage, is that okay? The first thing is to click on what? On standard contour. There are situations whereby we use a user defined contour and threshold contour. Right? What we are going to be using is what? Standard contour. I'll click on this. All right, that's okay. You can see our legend here. Can you see it here now? So once we have this one now, the next thing is to start loading this. So my loading will start from where? From M1. Is that okay? All these MX, MY, this all of them, they are also okay, but the load is actually very, very small. Is that okay? You can start from M1. Is that okay? So I'll start from here. Is that okay? Let's start loading this one also. Okay, load this one also. Okay, no, let's start from here. Yes, let's start from here. Sorry, let's start from here. Let's start all over from here. And this one, let's load everything together. Is that okay? Okay. Yes. Okay. Okay. Next thing is here. Next thing is here. All right, next thing is here. At this stage, if you see anything like a, what do we call it, section is sufficient, is that okay? What it's talking about is what is your slab, which you might need to go and do what to increase it. Is that okay? All right, from 175 to maybe, like now we are using 175, you can go ahead and increase to up to what? Up to 200. And if you make 200 and on getting to this place, you are still giving you that one of a section is sufficient, then you can go back again and increase it up to 250. Is that okay? You can increase it up to 250, and if you increase up to 250, I will get it together. If you increase up to 250 and you come back again and it's still telling you section is sufficient, you can ignore it. The reason why I say you can ignore it is because if you look at the way we model this structure, it's not the slab that is carrying the load. What is carrying the load is our beams. Is that okay? Which means our area of concentration will now be what? On our beams. Is that okay? All right. So click on this. Finally, click on this. Okay, click on this. Correct. So now you can see that we have actually loaded all of this. Is that okay? Since we have loaded all of this now, the next thing to click on soil pressure. Is that okay? On our soil pressure. So I'll now click on what? On my soil pressure. Where is it? You can see this one here. I'll click on it and let's see. Let's see what we have. Is that okay? All right. This is 231. Is that okay? 231. Now that we have 231, if you now look at this place, now you can see it's telling us okay. This one is 225. Is that okay? 225. So if I go around, and this particular one you are seeing, it might be at the edge, around the edges. Is Is that okay? Somewhere around the edge. Is that okay? Somewhere around the edge. So how do you now know your own? Because this is a structural pressure. Is that okay? This one is a structural pressure. How do you know the soil pressure? You can pick your calculator. Pick your calculator, and now from here now you can now say what's our soil pressure? Soil bearing capacity is what? 180. Is that okay? 180 then multiply by what? 1.4. Is that okay? So give us what? 252. Is that okay? 252. So this 252 now is greater than what? 231.170. Is that okay? Which automatically means what? This particular what do you call it, structure foundation is very, very okay at this level. Based on this level, it's very, very okay because the soil pressure is greater than what? The structural pressure. This is our soil pressure, and this becomes our what? Structural pressure. 231 is structural pressure, while 254 is our soil pressure. Is that okay? All right. So at this point now, I can now click on what? On close. Please, the process of this is different from that of Protastructure 2022 and above. Is that okay? Once I click on this now, something will come up. Can you see now? It's asking transfer slab, ship this, whatever, everything here. Now say yes. Okay. Is that okay? For you to do that, I click on okay. So and now let's now wait so that it will transfer all the loads. Is that okay? On this. Is that okay? So now it might take time. So to avoid that too much time, so I'm going to pause this video and let's see how it, can you see that started transferring slab strip results. Can you see it now? At what x direction? That's axis 7. Can you see now? 8. It's now on 8. Is that okay? So that is how it's going to work. So let's wait for it. Alright, so it has finished. From that point, it has reached. Automatically it will come back to this. And once it comes back to this, don't forget to click on what? Transfer foundation beam result. Is that okay? Transfer foundation beam result. I will now click on what? On this. Is that okay? And let's wait. Can you see? Foundation beam finite element result are what? Are transfer. At this point now, I can now click on what? On close. Is that okay? So now let's now see our reinforcement. Is that okay? Alright, so what I'll do, I'll right click and click on update silver. Can you see? Then click on this and let's wait for it. Okay. Okay, it has come. So can you see it now? So can you see what we are having? Can you see Y16 at the space of 250? Can you see it? And this one also, likewise this one also, Y16. So you can see what we are having. Can you see Y16? All of them Y16, Y16 for our slab. Can you see it now? So now, now we are done with what? With our what do you call it? With our slab. We have known the kind of reinforcement we are going to be using for this. Is that okay? We are going to know the kind of reinforcement we are going to be using for this particular aspect. Then, but if you now look at this, okay, let's go to 3D. Okay, but if you look at it now, our beams have not been designed. Our beams have not been designed. So how do you now design your foundation beam now? Is that okay? How do you design your foundation beam for this? So I'll come to, now let's now go to where do we call it? Design. Can you see? Go to concrete design. Don't forget we are using Protastructure 2018. Is that okay? I'll come to this beam reinforcement design. I'll come to what? Foundation beams. So if you look at the foundation beams, they have not been designed. Is that okay? They have not been designed. So since they have not been designed, I'll come, before you can design this, you cannot just go to what? Beam design batch mode. No, there are some settings you need to do. So I'll click on this one now. Let's wait for it. Okay. In this place now, you can see that we have a design. Under the design, you can see what we are having here. So what are the settings here? Under the design, you can see concrete cover. Is that okay? Concrete cover, we use what? 50, because on the ground it's touching the ground. Based on code, our minimum concrete cover is what? Is 50. Though at times we normally use a 35, 50, 35, but let's use 50. Is that okay? Let's use 50 for both. Is that okay? 50, 50, 50. Is that okay? Our concrete cover 50, 50, 50. I'll now come to parameter. From this parameter now, can you see minimum foundation steel diameter is 16. Then maximum foundation, I'll use what? I'll use 20. Come again. Okay, this one again. This one is okay. Then what about the spacing? My spacing, let me use to 200 instead of 300. Let me use to 200. My spacing, let me use to 200. Sorry, to 200. Is that okay? To 200. Minimum 100, maximum 200, 25 and 200. So which is okay. Then you can now see that we have selected it. You must have value here. Is that okay? Minimum and maximum, you must have a minimum and maximum. And when it comes to your link, there must also be minimum and maximum. Is that okay? Alright, so I'll come to my parameter design again to confirm. Okay, everything here is okay. So let me come here. Is there anything? No. Anything here? Okay, this one is my pattern. Okay, let me see. Merge similar bottom bar. Okay, it's okay. What about merge similar span top bar? Yes. This one also, the two are needed. So come to this place detailing and come to this place section. Okay, I'll use this one and then this one. Okay, to provide a single one. Is that okay? I'll also come here. Okay, this pattern is okay. This one is okay. Use all struts. Is that okay? Come to dimension and remove this bulb. Is that okay? All these ones I don't need it. Click on this. Check this one. Okay. This one and this one, they are not needed. I don't need this one. Is that okay? These are my settings. So I'll come to this place now. Come back. I think everything's okay. I'll just click on what? On save. I will say, do you want to update everything? Yes. Yes. Click on update. Save already. Let's wait for it. Let's wait for it. Okay, so now it's at this point now I can now go ahead and click on what? Design batch mode. Beam design batch mode, and click on reselect and then click on what? Calculate. So let's wait for it and see what we are going to have. So it has started. Let's wait for it. All right, so as you can see, we can now click on one close. So you can see that they have all designed. So if you now look at it, all of them are less than 1. Is that okay? All of them are what? Less than what? 1, except this particular one. So this is how you go about it. If I click on this one now, interactive design, let's say I just click on this. Is that okay? And then you can see why it's showing us what we call it, that this thing is all about adjustment of these ones. Is that okay? Adjustment of all of these ones. Is that okay? Can you see it has passed? Can you see? So it has passed the design. These are just the issue, this particular one. And if I look at this one, okay, this one is still okay. This one is still okay. It's still okay. I can click on this. Can you see it now? So this is it. Now I'm not doing any interactive design. Is that okay? This one need adjustment. Can you see it's less than 20? If you watch our video during interactive design, there are a lot of things we normally discuss. Is that okay about interactive design? Is that okay? And if you look at number of reinforcement, like this one now, they are much. How do you go about it? That will be in our next class. God's willing, we'll be able to do that. Is that okay? Justice to that. Is that okay? When you're having too much reinforcement, what and what are you expected to do? Is that okay? All right, click on this. All of this. So this is how you go about it. Is that okay? So during interactive design, all the adjustments will be made. Is that okay? All the adjustments will be made. Is that okay? Properly. That's during interactive design. Okay, just okay. Okay, let me just click on this one. Okay, also. Okay, let me just okay this one and this one. I purposely left that one of 1, and so you can see this one too. They need adjustment. Is that okay? They all need adjustment here. Is that okay? You can see that it's filling here. It's filling on this. Is that okay? It's filling on this. All right. So it's passing at this. So what are we going to do to this? Everything will be done in our next video. God's willing. Is that okay? If you can proceed, but at least, as I promised, concerning the foundation, at least we have reached that foundation stage. Is that okay? If you want to know how to interact, to do your interactive design, you can watch our previous videos. Like this particular one now, there was a point, I think, is it a part 5 or part 6? Is that okay? I think no, it was part 7. I think it was part 7 I did the interactive design. So go and learn how to do interactive design. If you're able to understand that, you discover that to interact with this one and make all this correction will not be difficult. Is that okay? All right. So during interactive design, all of this will be solved. Can you see this place now? Can you see this place? So this place must not show red. Is that okay? We don't want all these ones. Okay, this is okay. AS minimum. Okay, so it's okay. It's okay. It's okay. It's okay. All right, but this particular number of reinforcement has to be done. Something have to be done. Is that okay? All right, and some things you consider apart from all these values here. There are other things. So watch our interactive design, which is a part 7. Is that okay? Part 7 of this. Is that okay? Let's see. Okay. All right. So all of this, you can see that the reinforcement are scattered. There's a way you arrange it. Is that okay? Also watch that part. Is that okay? You will see everything done perfectly well. Is that okay? Okay. Let's see. Come up. Click on this. Click on this. This one. Can you see? Perfect. So, and let me see this one. Okay. This one. This one. Okay. Number of reinforcement is what we need to adjust, and this one. Okay. All right. So, can you see? We are good to go. We are good to go. We are good to go. The only thing we are left with is how to make the proper arrangement of this. Is that okay? So, for example, let me just click on this and make it standard 3. Let's see. Standard 3 of this. So, can you see? You still need some adjustments to be done. Is that okay? Arrange it properly how you want it to be done. Is that okay? All right. So, can you see it now? If I click on this, why is this one not what is the error? What is it all about? Okay. 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 Let me see. Where is it? It's all about the top. It's about the top value. Let me see 5. Okay. All right. So I now click on this. Can you see that's reduced to what? 0.8. Can you see now? There was something I saw there that made me to say, okay, there's need for more bars there. And looking at that more bars, I don't really want it. And how do you go about it to reduce the number of bars? Go and watch the part 7 where we did the interactive design. Is that okay? So if you now look at this, you can see how we have designed this foundation now, our foundation beams. Is that okay? Even though we have not really done the proper interactive design, but at least the first stage, our what design is showing all green, which is pass number 1, and pass number 2, your utilization ratio, everything is what less than 1. Is that okay? Even though we have a 0.9 something, but at least it's still less than 1, which is still okay. By the time you do your interactive design, definitely it might even go below this 9.8, for example, this one. Is that okay? All right. So let's now go back. Let's now click on close. And now, can you see what we have now? Can you now see? Can you now see how we have designed this? Can you now see how we have successfully designed the foundation? Can you see everything have passed design? Is that okay? What we are left with now is the arrangement of our what? Of our what do we call it? Beams reinforcement, beam reinforcement. So can you see it now? So thank you so much. So this is how you go about your beam raft design. Though there are another part to this beam raft design in a situation whereby your structural pressure is more than the soil pressure. How do you go about it? That's another phase. Is that okay? Why we not go ahead to do that is because our soil pressure is more than structural pressure, but it's still advisable to still go ahead and provide some things around your beam for some reasons. Is that okay? But without that, this one is still okay. Is that okay? Depending on the condition of that area. Is that okay? So but with this one is still perfectly okay. Is that okay? So thank you so much for watching this video from beginning to this stage. I want to say, in case you have not watched the other part, which is part 1 to 7, before this part 8, I want to say, please do that so that you understand it properly. Is that okay? And with that, you'll be able to have confidence in whatever design you are handling, especially the one that is going to have what we call a beam raft. Is that okay? And I've explained the reason why we came about what beam raft. We have tried to use a patch, and you can see how it was failing. Is that okay? Which we are now explaining that we have to go for beam. What do you call it? If you can even see. Sorry, you can even see that we are using a beam depth of what? Of 1,400, and yet we are discovering that some things, some reinforcement need adjustment. Is that okay? So you can now imagine if you have gone to use a Y strip, and we know that the maximum beam for Y strip is 950. Automatically, it will not have worked, even though the strips work past the design, but the beams will not have passed the design, which might still prompt us to go ahead and use our beam raft. Do you get it now? So that is that. You can now see the structure now, how it has been successfully been designed. Is that okay? So thank you very much. Till I see you next time. I want to say, please don't forget to still click on like button, because the more they like, the more YouTube make this video to go viral. And I want to say, please also comment as you watch our video and tell others about Ekidel. Thank you so much. God bless you. One love. Keep us together. Bye.